Every day, Americans throw away over 700,000 tons of garbage, enough to fill more than 60,000 garbage trucks daily. Imagine that. Mountains of trash stretching from coast to coast, piling up faster than we can bury it. But what if that waste didn't have to end up in a landfill? What if it could become electricity? Welcome to the supergiant waste-to-energy plant, where engineers and scientists have turned the nation's garbage problem into a source of clean, renewable power. Today, we'll journey deep inside one of America's most advanced facilities to see how mountains of trash are transformed into megawatts of energy that light up homes, power cities, and reduce landfill waste in a mind-blowing process. America produces over 292 million tons of municipal solid waste every year. That's about 5 pounds of trash per person per day, the highest in the world. For decades, most of that waste was simply buried in landfills. But landfills release methane gas, one of the most powerful greenhouse gases on Earth. In the 1970s, engineers started asking a radical question. If trash contains energy, why are we just throwing it away? That question led to the birth of the waste-to-energy (WTE) movement. Instead of burying trash, these facilities burn, gasify, or process waste to recover usable energy, mostly electricity and heat. Today, more than 70 waste-to-energy plants operate across the United States, handling over 30 million tons of garbage every year. Each ton of trash processed here generates enough power to light up a home for 2 weeks. But how do they do it? Let's dive inside one of the most advanced and massive of them all. The story begins at every home, business, and city street corner. Garbage trucks collect tons of mixed waste, food scraps, packaging, plastics, papers, broken furniture, and head toward the enormous waste-to-energy facility. When the trucks arrive, they enter a giant reception hall, larger than a football field, known as the waste bunker. Here, operators dump the waste into a massive pit that can hold 10,000 tons of garbage at once. Towering overhead, crane operators maneuver giant claws, each weighing several tons, to mix the waste, ensuring an even blend of materials. This helps the combustion process later on. Every few minutes, a claw grabs nearly 5 tons of trash, lifting it high above the pit and dropping it into the feed hoppers, where it begins its incredible transformation. Inside the heart of the plant lies the furnace system, an engineering marvel where temperatures exceed 1,800 degrees Fahrenheit. Here, the waste travels along moving grates, slowly burning in controlled stages. Unlike an open fire, this is a precisely managed combustion process that maximizes energy recovery and minimizes emissions. As the garbage burns, it releases hot gases and energy. That heat is captured in boilers filled with water, converting it into high-pressure steam. This steam then drives massive turbines, the same kind you'd find in power plants, generating electricity that flows directly into America's power grid. Every ton of waste burned produces about 550 kilowatt-hours of electricity. Enough to power a modern refrigerator for an entire year. Meanwhile, the combustion process reduces the original volume of trash by nearly 90%, leaving behind only ash, which can be further processed to extract metals or used in road construction. Now you might wonder, doesn't burning trash pollute the air? That's where cutting-edge technology steps in. Modern waste-to-energy plants are equipped with multi-stage filtration systems that remove harmful gases, heavy metals, and particulates before anything is released into the atmosphere. The result? emissions cleaner than most industrial facilities, often meeting or exceeding EPA's strictest air quality standards. At the same time, magnets and eddy current separators recover ferrous and non-ferrous metals from the ash, such as iron, copper, and aluminum, which are then sent to recycling centers for reuse. So not only does this process generate power, but it also recovers valuable raw materials that would otherwise be lost. The electricity generated by these supergiant plants is nothing short of astonishing. A single large facility can produce up to 70 megawatts of continuous power, enough to supply energy to over 60,000 homes. And across the US, all waste-to-energy plants combined generate around 2.5 gigawatts of electricity annually. But the benefits go beyond power generation. Each ton of waste processed here prevents 1 ton of CO2 emissions that would otherwise come from methane in landfills. Additionally, by recovering metals and reducing waste volume, these plants save millions of square meters of landfill space every year. It's a perfect example of a circular economy, where even our garbage becomes a resource. The concept of turning waste into energy isn't new. The first incineration plant in the US opened in 1885 in New York City, mainly to reduce the city's waste problem. But early facilities were inefficient and heavily polluting. It wasn't until the 1970s energy crisis that the idea gained momentum. With oil prices skyrocketing, cities began exploring ways to extract energy from their waste. By the 1990s, with advancements in combustion control and emission technology, waste-to-energy plants became one of the most regulated and efficient energy sources in America. Today, facilities like Covanta's Energy from Waste plant in Florida or Wheelabrator, Baltimore, process millions of tons of garbage annually, producing reliable, renewable electricity while keeping landfills in check. And as technology continues to evolve, engineers are now exploring plasma gasification, anaerobic digestion, and carbon capture integration. Turning what was once pollution into clean energy solutions for the future. If you found this journey fascinating, from garbage trucks to glowing cities, hit that subscribe button, give this video a like, and ring the notification bell, so you never miss another deep dive into the incredible world of mega factories and mind-blowing industries. Because here, every pile of trash hides a story of transformation, and we're just getting started. Massive cargo ship, or even a decommissioned Navy vessel, they can't just disappear. Some of them are longer than skyscrapers are tall, weighing more than 50,000 tons. Every year, the United States alone faces the question of what to do with hundreds of aging vessels. Military ships, tankers, freighters, and even cruise liners. The answer is one of the most mind-blowing industrial processes you'll ever see: ship recycling. Inside America's supergiant recycling plants, these floating giants are carefully taken apart piece by piece, until what was once a proud vessel sailing across oceans is reduced to valuable raw steel. This isn't destruction, it's transformation. It's the final journey of a ship, but also the beginning of countless new stories. Powered by the recycled materials pulled from its frame. But before the first cut is made, there is a crucial step: preparation. Ships aren't just floating steel shells, they are filled with decades of fuel residue, lubricants, asbestos, plastics, paints, and in older ships, even dangerous chemicals like polychlorinated biphenyls, PCBs. Leaving these inside would pose serious risks to workers and the environment. So teams of specialists go in first, wearing protective suits. They pump out leftover fuel and oil. They strip out wiring that may contain hazardous insulation. They remove asbestos from walls and insulation. They clear out refrigerants and chemicals. This stage can take weeks, but it's essential to making sure the rest of the dismantling process is safe and environmentally sound. Only once the ship has been declared clean does the real heavy work begin. Workers prepare massive cutting torches, cranes, and hauling equipment. The air is filled with anticipation, because soon, steel that once protected sailors or carried cargo across the Atlantic will meet the fire of plasma cutters, breaking down into manageable pieces. For many people, it's emotional. These ships often carry stories. Some may have fought in wars, carried humanitarian aid, or hosted thousands of passengers. But here in the recycling yard, emotion gives way to engineering. The focus is on safety, precision, and efficiency. What was once a proud ship is about to be reborn. Once the ship is stripped of hazardous materials, the real spectacle begins. Imagine a steel giant the length of the Empire State Building lying on its side. Taking it apart is nothing like breaking down a car. This is steel plate that can be 2 inches thick, welded together with military-grade precision. To cut it, workers use plasma torches, gas burners, and in some cases, giant hydraulic shears. The sound is deafening, sparks flying, metal shrieking as it's torn apart. Teams of workers climb scaffolding or hang from cranes, slicing sections of the hull into smaller, more manageable chunks. The process begins from the top. Superstructures like the bridge, funnels, and upper decks are removed first. Large cranes swing in, lifting away pieces that weigh dozens of tons. Every move is choreographed for safety. One mistake could bring down thousands of pounds of steel. Bit by bit, the ship's proud profile disappears. The tall stacks, once spewing smoke across the ocean, are reduced to scrap. The decks, once filled with crew or passengers, are cut apart. Finally, workers move down to the hull, the thick, reinforced belly that carried the ship across storms and seas. Cutting the hull is the hardest part. It's often done in sections, with each chunk weighing several tons. These are hoisted by cranes onto trucks or rail cars, ready to be sent to shredders or steel mills. Watching it, you can't help but marvel. A ship that once carried thousands of containers across the Pacific is now itself cargo, destined for a furnace. This dismantling process can take months. A smaller ship may be fully processed in 6 months. But for giants like aircraft carriers or oil tankers, the operation can last years. In Brownsville, one of the largest yards in the US, dismantling a single supercarrier produced over 100,000 tons of scrap steel. That's enough to build multiple skyscrapers. Not everything on a ship is just steel. Ships are treasure chests of materials. As the cutting goes on, crews separate different types of metal. Copper wiring is stripped from conduits. Aluminum is pulled from railings and fixtures. Brass fittings, bronze propellers, stainless steel piping, each has its own recycling path. Propellers themselves can weigh up to 20 tons and are worth hundreds of thousands of dollars in bronze scrap alone. Even the engines, massive diesel machines as tall as a 2-story house, are taken apart. Components are sold for reuse, while metals go into recycling streams. Plastics, insulation, and wood are sorted out. Some can be recycled, others disposed of safely. Nothing goes to waste if it can be avoided. A modern U.S. ship recycling facility aims to recycle more than 95% of a vessel's weight. It's a process of triage. What goes to steel mills, what goes to copper smelters, what goes to secondary markets. The workers are not just cutting, they're sorting, recording, and ensuring that every valuable piece is captured. So what happens after the giant chunks of steel leave the yard? They're shipped to steel mills across the United States. There, the scrap steel from old ships is fed into electric arc furnaces. Temperatures reach over 3,000 degrees Fahrenheit. In minutes, the ship's steel becomes a pool of glowing molten metal. Impurities are removed, and alloys are added depending on the desired grade. That molten steel is then cast into billets, blooms, or slabs. These, in turn, are rolled into beams, sheets, or rebar. And just like that, the ship is reborn. Maybe it becomes the skeleton of a new skyscraper in New York. Maybe it's transformed into rebar holding together a bridge in California. Maybe it's rolled into plate steel for a brand new cargo ship. The cycle is complete, from sea to land, from past to future. Every ton of recycled steel saves about 1.5 tons of iron ore, 0.5 tons of coal, and reduces carbon dioxide emissions by nearly 2 tons. Recycling ships doesn't just recover material. It avoids the environmental costs of mining and refining virgin ore. Ship recycling is not without its risks. In some countries, it has been notorious for environmental pollution and worker injuries. But in the US, strict regulations ensure that the process is safe and responsible. Before any cutting begins, all fuels, oils, and hazardous chemicals must be removed. Wastewater is treated. Air emissions are monitored. Workers are trained and equipped with protective gear. This is crucial because older ships can contain asbestos insulation, lead paint, or PCBs. Mishandled, these could cause harm for decades. But in modern American yards, these substances are safely removed and disposed of in accordance with EPA standards. The goal is not just recycling, it's green recycling, ensuring that the process of rebirth doesn't harm the planet. Why is ship recycling so important? The economics tell the story. A single large tanker or carrier can yield over 50,000 tons of steel. At today's prices, that's worth tens of millions of dollars. Add in copper, aluminum, and stainless steel, and the value climbs higher. Multiply that by the hundreds of ships decommissioned each year worldwide, and you get a multi-billion-dollar industry. For American yards, this means jobs. Welders, cutters, crane operators, environmental specialists. Entire towns in Texas and Virginia thrive on the ship recycling economy. And beyond jobs, it feeds America's steel industry. The US is one of the world's largest recyclers of steel, and ship scrap is a key contributor. If you found this journey into America's supergiant ship recycling plants fascinating, make sure to subscribe to our channel. We bring you more incredible behind-the-scenes stories of how the world's biggest industries work, how materials are reborn, and how our future is built. Don't forget to like this video, share it with friends who love engineering and discovery, and hit the bell icon so you never miss our next deep dive. Every year, Americans use over 100 billion plastic bags. That's more than 300 bags for every single person in the country. But have you ever wondered, where do all those bags go once they've been used? Do they end up choking landfills and oceans forever? Not anymore. Across the United States, supergiant recycling plants are taking these flimsy single-use plastics and turning them into something new. Packaging, pallets, decking, and even brand new bags. Today, we're going inside one of these incredible facilities to witness how billions of bags are given a second life. Before we begin, don't forget to subscribe to the channel, because we bring you the most mind-blowing processes happening inside the world's biggest factories.